Hi everyone, my name is Zafix. Last week I did two Perl 6 talks at the Toronto Perl Mongers meeting, but this time it's unclear if we can get access to the video recording of that talk. So I figured I would do a screencast of it. This way anybody who could not attend those talks could still get access to the content. So one of those talks is called Faster Perl 6 Programs, and I will show some tips and tricks for getting better performance out of your Perl 6 programs. You can get the slides for this talk at tpm-perf-perl6party, and I remember some of the questions that were asked during the talk, and I will try to recreate them, but other than that, just enjoy the talk. So if you ever tried to use Perl 6 or you read some reviews of it, you might have heard that it's slow, and the reason for that is that it's not a new version of Perl. It's an entirely new language. It was first released on Christmas 2015. A lot of work still needs to be done for the optimizations, and it's a largely volunteer-driven project. So some things take a bit more time than some commercial project. If you compare Perl 6 with some older language, you will find a difference. In an older language, if you change a program slightly, you would usually expect the performance of it to stay mostly the same. But in Perl 6, because some things are not yet optimized, you may find that one construct is really slow, and if you change it slightly, it might be a lot faster, maybe even faster than one of the more established languages. So one of the solutions to this problem is to simply wait for core developers to make everything fast. For example, in this code example, if you create sets, in last release, this program took 81 seconds. On a development commit that will make it into the next release, it now takes just half a second, so it became 161 times faster. Now, of course, this process will take some time, so if you don't want to wait for it, you could learn to avoid all the things that are slow and just use the fast part of the language in programs where you care a lot about performance. Some tips to achieve that is to keep your programs simple. Pay attention to numeric types. Try to avoid using regexes if you don't have to use them. Make use of native types, and as well use the built-in profiler. And if you find something that is really slow, be sure to file a bug report so the core developers could take a look at it and see why it is slow. For keeping it simple, just use enough features for your program to get the job done. Perl 6 has a lot of different features, and you may be tempted to combine them in all these crazy and clever obscure combinations, but because few people would have done the same thing, chances are that you will hit something that's not optimized. So the more common the code is, the structure of the code is, the more optimized it would likely be, because simply because more people would use that code and notice that it's slow and be more interested in optimizing it. Here we have an example, and this is common with people who have a Haskell background. They start to put type constraints on everything they can possibly put the type constraint on, and often not only that makes the program slower, it's not really needed. The dynamic optimizer, it can remove some of the type constraints if it can see that some of them might not be needed, or if it sees the same type being given to the subroutine, it will kind of change it to a cheaper guard instead of a type check, and basically it will make the program run faster. And if that guard fails, it will switch to a slower version of the program. So there are some dynamic optimizations that kind of make type constraints cheaper, but some of them it would be beneficial to remove them. In this code example, we use a where clause to check every element of the array, and that's a runtime check. So that will have cost. And the other thing we're doing, the map method returns a sequence, but we take this sequence and we create a parameterized array from it just to type check everything and return that. So that's another thing that is also a runtime operation that we can get rid of. So if we do that, so we kept the num type constraint on that variable, but the rest we got rid of, and this made our program 2.7 times faster. And it's not exactly the same as the last one, but I think in most cases it would be enough. So for example, if you call that subroutine with something that doesn't have a flip method, the program will crash. The same like throw an exception, the same as a type constraint exception will be thrown. So you're not really losing a lot by removing some of the type constraints. Here's one of the examples with regexes. You can use a variable that has a list in it directly in the regex, and this will be interpreted as a list of alternatives to match. You can also use a code block, and inside of it generate something that should be interpreted as a regex. For example, in this code piece, we pick a random number and use it as a regex. So one of our users combined those two features, and they've used a code block to generate a list of 256 alternatives, and then they used a quantifier to match 4 of those alternatives to match an IP address. And if you know Perl 6 regex syntax, this is a really simple code, but a single iteration of this runs more than 8 seconds. That's ridiculously slow. So some of the reasons why it is slow is we've used a code block, and at least right now the evaluation won't be cached. Like it doesn't know if the code block will produce the same value each time at the moment. So because of that, the block is called 4 times because we are asking for we have the quantifier that asks for this block to be matched 4 times, and each time we create a new regex from the returned list. So we have 256 alternatives, which in total is more than 1,000 alternatives. And there's probably some other cause for the slowness as well, which is why this user filed a ticket, a bug report for us to look at. So we can modify this program. We can simply move out that list of alternatives out of the regex and simply keep it in a variable, and then we just use that variable inside the regex. So the program still does the same thing it used to. Functionally, it still matches the IP address, but now it runs only in 500ths of the second, which is 163 times faster. So by making this tiny change and not combining all these different features in obscure ways, we were able to make our program a lot faster. In some languages like Perl 5, it doesn't really have numeric types. So for example, you can store a fractional number or an integer in the same sort of object. In Perl 6, there are several different types. Some of them offer different precision. For example, we have a rational type, that is basically a fraction. It consists of numerator and denominator, which are two integers, and that's the default type you get when you use a dot in a number. So in this example, we have dot 1, 2, 3. That's a rational number. We do some simple mathematical operation on it, and just a single calculation of this routine takes almost 20 seconds. That's unbelievably slow, and not something you would expect from such a simple calculation. So if that's the thing you try and that's the speed you see, you may assume that Perl 6 is a terrible language, that's slow. Somebody who told you that Perl 6 is slow might have been right, and you might not even explore the language further. However, the reason it is slow is because you're using this rational number. So what happens is you are raising these two integers, the numerator and denominator, into a huge power, and then you try to reduce them when you produce the output. So we don't need any crazy precision in this calculation, so we're going to change the rational number to a standard floating point type. That's the num type in Perl 6. And with literal numerics, all you have to do is append e, and in this case we use 0 as the power, as the exponent. So we change the num to the rational to num type, and our program is now the first example. A single calculation took almost 20 seconds, but now a million calculations take less than a second. So I don't know how many times it's faster, but I think it's like 21 million times faster with such a tiny and small change. So be sure to pay attention to what numeric types you are using. If you don't need super precision, if you're not doing some financial operations or something where it matters, switch to num type and you will get a lot better performance. There's another optimization we can make to this routine, and that's the is pure trait. When you apply it to a subroutine, it's an indication to the compiler that it can constant fold this routine, and basically it will perform this calculation at compile time. So we have a loop with 1 million calculations, but it will calculate it only once at compile time with this value, because it knows that value at compile time. So once it calculates the result, it will just plug it in here. So even though we're iterating 1 million times, we're calling our subroutine just a single time. And during the actual talk, somebody asked there was a question about how this works exactly. So I showed this small example. All right, I have a busted terminal. Let me grab something. 1 second. Okay. So one of the examples that I created during the actual talk is a subroutine that is marked pure, but it actually prints something. It has side effects. And usually you should not do this because, well, you don't want the side effects are not like you will only get the side effects once, not each time you call the subroutine. So that's why you shouldn't use the is pure trait on routines that have side effects. But in this case, we're going to just see how it works. So we call the subroutine 3 times inside our program, but when we run this program, it printed the output just once, even though we technically executed the subroutine 3 times. It printed just once. That's because it executed it at compile time, created that value, and ran the subroutine just once. And you also get a warning that basically it thinks it's a constant expression and you're not really doing anything. And if we remove that trait, you see it now, we get 3 outputs. That's because now it's being called at runtime 3 times. So basically this version of the program is 61 million times faster and 2 times faster than without the is pure in this particular case. But even if I were to bump this 1 million iterations to a higher value, the cost of calling the subroutine would remain the same, because it's being called only once at compile time. Not a lot of the optimizations have been done with Perl 6 regexes, and so they're not as fast yet. And also they produce richer data structures. They produce a tree of match objects, unlike some other languages like Perl 5. So if you compare Perl 5 and Perl 6 regexes, you will find a lot of difference in performance. And this means that you should try to avoid using the regexes for everything. For example, if I'm writing Perl 5 and I need to check if a string starts with some substring, I might use the regex. It would be really fast to use that. But in Perl 6, this program takes 9.2 seconds to run, which is not really fast. But there are some methods on strings that are designed precisely for this kind of operations. For example, we have starts with method, and that's when we change the regex to this particular method, we make our program 76 times faster. So that's another way you can improve performance of your Perl 6 regexes. Just use a more appropriate routine than just the regex. Another nice feature in Perl 6 are native types. They are written in lowercase, and they use the representation provided by the virtual machine, operating system, and hardware. So basically, for example, int 32, or actually just the int, if you are using more VM, that's the most popular virtual machine for Perl 6, then it's 64-bit, and if you go over those 64 bits, it will overflow, just like similar behavior to how you would get to what you would get in C, for example. Let's compare a Perl 6 program with another language, such as Perl 5. Here I'm using Perl 5.28. It's a small program where we have 5 million iterations. We are using a counter, and we push that on each iteration we store a value of the counter in an array. In Perl 5, this program takes 0.4 seconds. If we change that program to a Perl 6 version, you can see it's pretty much the same thing. We just changed push from a subroutine to a method. And in Perl 6, it takes 6.2 seconds to run, which is a lot slower. And somebody actually ran this program, and they've used it to evaluate the entire language, and in this particular program it was 10 times slower than Perl 5. This person said solid F, I'm gonna stick with Perl 5, and basically they made the mistake of assuming that the entire language is super slow just because this one specific program is slow. But we can change this program to native types, because we never use more than we never use integers that are larger than 64 bits, so we can get away with using native types. The only changes we made to the program is we added this type constraint on an array, so it's now an array of native integers, and we added this type constraint on our counter as well. So if we execute this program now, instead of 6 seconds, it takes only 0.13 seconds. And Perl 6 has a slower start type time than Perl 5. But even if you include it, you only get 0.27 seconds, which is actually faster than Perl 5 and is 43 times faster than our original program. So this is one of the cases where in Perl 6 you get better performance than in some of the older languages. And one of the reasons why this is possible is because we use something that's called JIT, that's a just-in-time compiling. And basically what happens is at runtime, the dynamic optimizer looks at your program and say you have a loop with 1000 iterations doing something, and it watches this loop and it sees that around 200 iterations it sees that you are calling the same routine with the same stuff all the time, and it actually will modify it. It will change. It will switch to basically assembly machine code for some instructions that are called a lot of times. And so you're calling this loop 1 million times. You have 1 million iterations or 1000 iterations. The first 200 may be slower, but then it switches to this faster mode, and the rest of those iterations will be really fast. So that's how you can basically have better performance. And during the talk, somebody asked us if we expect, like, how optimistic our core developers are that we will get better performance, and my answer was that we don't like to promise everything, but we hope to be eventually faster than Perl 5. And in this particular program, we are already faster in this contrived example that's limited to being lower than 64 bits. But that's not the only program that I know that is faster than Perl 5. There are other cases. So I think, and also there's a lot of work that still needs to be done. So I think eventually we will get good performance. And so yeah, so personally I am optimistic that we'll have good performance. That was my answer to the question. And here we have this user who gave us solid F grade. So they realized that there are ways to write Perl 6 in a performant way. When you use native types, keep in mind that they don't have any methods. If you try calling a method, they will get out-of-boxed, which means basically they will get converted to non-native version, and this can cause a performance penalty. For example, in this code we call ABS method. Original runs in 0.29 seconds, then we switch to native types, and we lost 60% of performance because it has to do all the boxing to get the object that has a method in it. But a lot of features have a subroutine form, and a lot of them can work with native types. That is the case for the ABS method. So we made, instead of using a method form, we switched to a subroutine, and now we are getting the benefit of the native type, and the performance is 260% faster. Perl 6 comes with a built-in profiler. It has a bunch of features that you can read about at this link. And the way you use it is you specify profile command line parameter, give it a file name. In this case, I'm using HTML output. It supports some other formats such as SQL. And we're going to profile the subroutine that was super slow, this mathematical subroutine. So when we run this program with the profiler turned on, it will generate the HTML file. We just open it in any web browser, and here's some of the things that we'll see. Usually the locations of the subroutines will reference your code, like the code in your program. But in this case, because our subroutine is so small, and the slow parts are actually the core subroutines, it references core locations, and you can tell those because they have this prefix setting. That means it's from the core, and you can find these locations in this repository if you're using the Rakudo compiler. And a lot of the code is basically Perl 6. We do use NQP, which is it stands for Not Quite Perl, but in a lot of cases you can treat that stuff as basically a module, a Perl 6 module that you load it. So a lot of the code is basically would be familiar to you if you want to take a look at it. So in this case, even if you are not familiar with core code, you can see that the profiler 99.8% is spent with a rat type, doing something with a rational number. So from that you can surmise that the reason your program is slow is because something with a rational number, something is being done with a rational number, and you can make appropriate changes. There's currently a grant, an active grant from the Perl Foundation to design better tooling in performance analysis tooling. So once that grant is completed, you will have even better tools that you have right now. And if you have some piece of code that you want to be really fast, but you're having trouble optimizing it, you can just join our support chat and talk to other Perl 6 programmers, and usually you will get a lot of good help trying to get better performance. And that's it for this talk.